talking about graphing quadratic functions in intercept form and transformation of the quadratic functions in factored form. So we have the graph h of x equals negative times the quantity x plus 2 times the quantity x minus 4. So again, in order to find the x-intercepts, we want to use the zero product property. And so we have two products here. Actually, we have three with the negative, but the two that we're concerned with are x plus 2 and x minus 4. So if either of these are equal to 0, then the whole thing's going to be equal to 0. That's a zero product property. So we'll say x plus 2 equals 0, and the way that we get x by itself is we subtract 2. So we get x is equal to negative 2. So that tells us that at negative 2 comma 0, we have a 0. Or the graph will cross the x-axis. Do the same thing with the other one. So x minus 4, set that equal to 0. Add 4, and we get x is equal to 4. So we have a 0 at 4 comma 0. So we can plot those 2 points. So 5, 5, negative 5, and negative 5. So 4, 0, and negative 2, 0. Those are the points that we just plotted right there. And now the next thing we have to do is we have to calculate the line of symmetry. And the line of symmetry we calculate by averaging our two zeros. So we know that x is going to be equal to something divided by 2 because we have two zeros. And in this case, we have negative 2. And we know whenever we calculate average, we're adding them together. So negative 2 plus 4. So negative 2 plus 4 should be positive 2 divided by 2. So in this case, our line of symmetry is at x equals 1. So I'm going to graph my line of symmetry at x equals 1, which is right here. So we draw a vertical line at x equals 1. And the next thing we have to do is we can check it real quick. How far is it from the line of symmetry to this point? So we'll go 1, 2, 3. Okay. How far is it to the other side? 1, 2, 3. Okay, my line of symmetry is drawn in the right place. The last thing I have to do is calculate if it's a minimum or maximum and find the vertex. Right here, the a value is negative 1. So the a value is negative 1. So because it's negative, I know that my parabola is going to open down like that. So there's definitely going to be a top. So I know that I'm looking for a maximum value. So I'm going to take my x value, which is 1, substitute it into the equation, and figure out what my actual vertex is going to be. So the equation is h of x equals negative times the quantity x plus 2 times x minus 4. And we're going to take the x value and substitute it in. So the function evaluated at 1 is equal to negative times plus 2 times 1 minus 4, and figure out what that's going to be. So our x value is 1. So 1 plus 2 is 3. We still have the negative out front, so 3. And 1 minus 4 is negative 3. So negative times 3 is negative 3 times negative 3 is equal to 9. So the function evaluated at 1 is equal to 9. So that means we have the vertex is going to be at 1, 9. And it looks like I don't have my axis drawn high enough, so I'm going to change that to be 10. So I'll make this number be 10 right here, and this number right here will be negative 10. And we'll use that to graph it. So now we're at the point 1, 9. So over 1, up 9. So 2, 4, 6, 8, 9 is right there. So we have the vertex, and we have the x-intercept and the other x-intercept. So now we can draw the line that goes between them. It should be curved, and they should both meet up at the top. And then we have a pretty good parabola drawn. And then we can take a look at the graph, and we see we have a point at 1, 9. Then we go over 4, 0, and negative 2, 0.